Welcome to this IEA 4E Mapping and Benchmarking webinar, which looks at the energy performance of dishwashers across a number of countries. It's one of a series of webinars held under the IEA 4E Mapping and Benchmarking Annex, which are available via the website. The first step of the mapping and benchmarking process is to define the boundaries of the product to be analysed. For dishwashers, this was relatively simple. We decided to gather data on dishwashers of all types with a capacity of between 6 and 16 place settings, although we did exclude tabletop dishwashers. The metrics we wanted to present in the final report were the standard metric of unit energy consumption in kilowatt hours per cycle. We were also looking to present efficiency metrics, a simple metric in which the consumption is divided by the number of place settings, and an energy efficiency index, which was based on the EU method. We tried to gather data on a range of other metrics, but the data was only available for capacity, water usage, and cycle time. One of the main purposes of the mapping and benchmarking analyses is to compare the energy performance of a given product across different countries. For each product in each country, the energy consumption of the product in standard use is recorded using a test methodology. These test methodologies are often different between different countries, and in some cases those differences in test methodology have a direct impact on the energy consumption recorded. It's standard, therefore, in the mapping and benchmarking analyses to identify a test methodology to which all energy results will be normalized. The process of normalization is where you look at the differences in the test methodology and try and identify the impact that those differences have on energy consumption, and then adjust the result from a given test methodology so that it is comparable with a standard methodology which is being used for the benchmarking purposes. In the case of dishwashers, there are different test methodologies in the different countries as normal. These differences are many, but the major ones that have an impact on the energy consumption recording are the inlet water temperature, the load type and the content of that load, whether or not the drying of the dishwasher cycle includes a powered drying element. The soiling regime varies between test methodologies, and also their approach to the use of soil sensing technology is different. There are differences in the requirements for washing and drying performance, and there are also differences in the specification of water hardness and detergent type. For dishwashers, we have identified that these three areas, inlet water temperature, load size and content, and powered drying, are the main contributing factors to the energy consumption recorded under the test. We've decided to normalize to the EU test methodology because there were more data sets within the analysis that were recorded to that test methodology, or a test methodology that was very similar, and so we were adjusting the least number of data sets by using that test methodology. The other differences in test methodology were not normalized, mainly because it was considered that they were not having a significant impact on the energy consumption recorded. But even if we had planned to do so, we weren't able to establish a robust methodology for normalizing those things. In the results presented in this webinar, you should be aware that there are differences in the test methodologies in place that are not adjusted for in the final results, and as a consequence, comparisons of the performance of products in different markets need to be viewed with some caution. So let's consider how these three differences in test methodology have been normalized in this analysis. A full description of each step is available from the benchmarking report at the Annex website. For drying method, in North America there is a prevalence of dishwashers that use powered drying. The test methodology in Canada and the USA accounts for powered drying by running two test cycles, one in which the drying is switched off and one in which it is switched on, and the declared result from the test methodology is the average of these two test runs. The EU test methodology does not use powered drying, but at the end of the test cycle the load is dry, and therefore to make the North American results comparable, the results that has been declared have been adjusted to be equivalent to a full cycle unit energy consumption, i.e. including that energy that is used for the powered drying. This process was achieved by estimating the energy consumption that goes into the powered drying part of the cycle from a number of test cycles that were available to us from a test house. Full details are available in the benchmarking report. The second difference normalized for was the size and content of the load. This varies between all the different test methodologies as different number of dishes and glasses and cutlery and so on are used. The consequence of this is that the thermal mass of the load is different in each different test methodology. This matters because the load itself tracks the temperature of the wash and drying cycles as the dishwasher moves through its operation. It's particularly relevant again in Canada and the USA, which has a different approach to loading than the rest of the test methodologies. All the other test methodologies load a dishwasher to capacity no matter what the size of that dishwasher. In Canada and the USA, for dishwashers of 8 place settings or more, the dishwasher is only loaded to 8 place settings. Consequently, the thermal mass of the load in Canada and the USA for a 16 place dishwasher is significantly smaller than that in Europe and the other test methodologies. The way that we've attempted to normalize for this is as follows. We have estimated the energy required to raise the temperature of the load in each of the tests through a typical EU test cycle. The energy required to do this is then estimated, and the difference between that in the local test methodology, for example in the USA, and that in the EU is estimated. That difference in energy consumption is then added to the declared result from the local test methodology in order to make the unit energy consumption comparable with that in the EU. The final difference is the inlet water temperature. Obviously, the water in a dishwasher is heated for the wash and rinse cycles, and the temperature at which it arrives at the dishwasher will affect the overall energy consumption. The test methodologies specify the inlet water temperature, but it varies between 10 degrees centigrade, 15 degrees centigrade and 20 degrees centigrade for the different test methods. We're normalizing to the EU test method at 15 degrees C, and it's a fairly standard calculation which is included within some of the test methodologies to estimate the energy required to adjust the inlet water temperature to that 15 degrees C based on the volume of water and the specific heat capacity of water. This is a fairly simple normalization step and is fairly robust. Because it's robust, we are very confident in that aspect of our normalization approach. The other two areas are based on significant assumptions. As a consequence, our confidence in the normalization for drying method and load size and content is not so high. We do not attempt to quantify statistically confidence in the normalization approaches, but we use a more qualitative approach, and we would say that the normalization steps for drying and load size and content are of low to medium confidence. Of course, the impact of this confidence is dependent on the size and scale of the normalization that is undertaken for each of them. This is shown here in this table, which shows the range of impacts for each of the normalization steps across all the years. So for example, if you look at the powered drying normalization for Canada, across all the years of the analysis between 1996 and 2012, the impact of the powered drying normalization step in Canada was to increase the average unit energy consumption in Canada by between 5.3 and 6.1%. As can be seen overall here, therefore, if we accept that the inlet water temperature normalization step is reasonably robust, the largest impact of normalization is in Canada and USA for both powered drying and for the differences in the load. This means that our confidence in the final normalized results for Canada and North America relative to the benchmarking test is the lowest of those data that you see, and that other data sets are reasonably good. As a consequence, we must emphasize that caution is required when comparing the relative positions of the EU datasets with other datasets, but particularly those in Canada and the USA. The trends of those datasets is still reliable, but it's the relative position to the EU benchmarking test and the EU results that needs caution. So what is the impact of all these normalization approaches to the final results for each of the datasets provided? This table summarizes the data available to the annex for this analysis. There are 9 datasets and they are of different types. A number of datasets were provided as product registration databases with sales attached. For others, it was a product database with a sales average provided from another format. In the case of Austria and the EU, aggregated data was provided to the annex, but it was taken from a product database with sales weighting, and so it's considered to be fairly robust. So there are varying degrees of certainty in the quality of the underlying datasets. Then the normalization takes place in order to be able to compare them. And this, as has already been described, has an impact in the confidence as well. Again, the process for describing the confidence in the different results that are presented is not a quantitative one in this analysis. We use a qualitative system in which we use the phrases robust, indicative or illustrative. Robust means that the underlying data set is of a good quality and that no significant uncertainty is introduced by the normalization process, and therefore the result is very comparable with that of the benchmarking test. For indicative results, the underlying data is either got some uncertainty in it, or some part of the analysis, specifically the normalization approach, may have introduced an uncertainty that means that the comparison against the benchmarking test is not certain. The final category is illustrative, and in this case there is either significant uncertainty in the robustness of the underlying data, or the normalization approaches have introduced a significant level of uncertainty. Please be aware as you view the results in this webinar that these differences in confidence in the relative positions of datasets is a key aspect of the results. You do not need to remember all of the categorizations in this table because they are shown in all of the results as follows. Robust results are shown with solid lines, indicative results are shown with dashed lines, and illustrative results are shown with dotted lines on all of the graphs. Before we move on to look at the results of the analysis, a major aspect of the mapping and benchmarking analyses is to try and establish whether the policies that have been in place to improve efficiency in dishwashers have had any impact. This slide summarizes the major policies that are in place in each of the different countries in the analysis. There are a range of general policies in place, including registration databases, awareness campaigns and financial incentive programs, but the major policy interventions fall into 2 main categories. The blue part of this table shows the performance standards, both for energy and for other criteria, including water use, wash quality and dry quality. Energy performance standards are in place in all regions with the exception of Australia, which doesn't have any energy standards at all, and Switzerland, which is introducing them in 2014 to align with the European Union. Energy standards can be in the form of annual energy consumption or in the form of an energy efficiency index, and the table shows when they were introduced and the subsequent revisions. On the right hand side in the green area of the table, the second major policy intervention is labelling programs. Again, these were introduced from 1988 in Australia and in other countries, and now all countries have labelling programs, and there have been a number of revisions since, which are also shown on the table. Energy labels include water use, wash quality, dry quality, CO2 levels and running costs in different markets. There are also premium energy labels in the USA and Canada in the form of the Energy Star label. In order to understand the relative stringency of the energy performance standards and labels in the different markets, it is necessary to convert them all to the standard metric. In this case, we've chosen the EU Energy Efficiency Index, although it's not been possible in all cases. In Korea, the standard and label are based on a combination of water consumption and energy consumption, and it's not possible to disentangle that metric in order to turn it into an EU EEI. There are also differences in the way that the different markets define compact and standard, and as the metrics change for those two types of dishwashers, you end up with slightly odd looking graph in which the North American labels and standards go through an up and down bump in the middle. Despite these uncertainties, it is possible to draw some conclusions from this rather uncertain graph. Firstly, the energy performance standard levels in North America are significantly less stringent when you compare them to those in the EU. The Canadian and USA levels are shown in the yellow and purple lines, whereas the EU is brown, and it can be seen clearly that the Energy Efficiency Index is much higher in North America, allowing much higher energy consumptions. The second thing that you can draw is for the energy labels. The two dotted lines at the bottom are the EU energy label and the most efficient form of the Australian label. Despite the fact that there are no current models in Australia that meet this top level, it's clear that the Australian labelling scheme has the most aspirational label at the top of its range. So let's start to move on to the results, but before we do, there's a couple of things to note around the graphs. Firstly, each country has the same colour in each of the graphs, and so you should be able to familiarise yourself with the different country colours. Secondly, where possible, we always try to present the sales weighted average result. This is the average of all products bought in a market because it's the most representative of the average consumption of dishwashers in that market in a given year. Occasionally, however, because of uncertainties introduced through normalization or because of uncertainties in the quality of the underlying data, it is considered better to present the product weighted average. This is the average of all products on sale. The different types of average are presented on the same graph, so just note that if a country has an SWA after it, it's a sales weighted average. If it has PWA after it in the legend, it's a product weighted average. The first thing we're going to look at is the declared energy consumption. This is the energy consumption as declared in the local test over time. What's clear to see between 1996 and 2012 is that energy consumption has been falling in all markets consistently over that time period. The second thing that's very clear to see is that the dishwashers in North America, with Canada in gold and USA in purple, are consuming significantly more energy than those in the other markets. In 2012 in Canada, the average dishwasher is using around 1.35 kilowatt hours per cycle, whereas in the other markets it's closer to 0.8 to 1 kilowatt hours per cycle. Of course, this is the declared result, and so we know that there are differences in the test methodologies that impact on energy consumption. So it's at this point that we run the normalization for all of the differences highlighted earlier. The impact of those normalization steps is shown here. It's clear that the EU markets are still very close together, and in fact the Australian and Korean markets come closer in, and so down at the bottom we have a range of energy consumptions for dishwashers which is all very similar. However, the results in Canada and the USA have not come closer to the rest of the markets. In fact, they've gone slightly further away as a result of the normalization process. This is a significant difference in energy consumption, more significant than we've seen in any of the other analyses to date. And as a consequence, we felt it was necessary to take a look at these differences to see if we could establish whether this was realistic and reasonable, and if so, what was the cause. The first thing that we considered as a possible cause for the additional energy consumption in North America was that models in North America were just significantly larger. This graph shows the average capacity of dishwashers in all markets. What's clear is that capacities have not changed over time significantly. They're relatively stable, and they're very similar in all markets, including in North America. Whilst Canadian data wasn't available for capacity, it's considered to be very similar, if not the same, as the USA, and the USA is closely bunched in with the other markets at around 11 to 12 place settings as an average capacity. In fact, the only market with a significantly different capacity is Australia, which is slightly higher than all the other markets. As a consequence, it seems unlikely that the capacity of the dishwasher is the cause of the additional energy consumption in North America. The second issue that we looked at was water consumption. Much of the energy in a dishwasher cycle goes into heating the water, along with the fabric of the dishwasher and the load itself. If dishwashers in North America are using significantly more energy than those in other markets, this may be a cause of the additional energy consumption. The average water consumption is shown in this graph here over time, and whilst it's falling also in all markets, it's clear that in Canada, for which we have data over the whole time period, the water consumption is significantly greater than that in, for example, Denmark or the UK. This additional water will require heating through the load, and therefore is going to contribute significantly to the additional energy consumption. There is another aspect to it, however. In North America, dishwashers are almost entirely hot fill. As a consequence, the water that's used throughout the cycle is all heated. In Europe and the rest of the world, dishwashers are almost entirely cold fill. And the dishwasher cycle is designed such that the water is only heated for certain parts of the cycle. So not only is there more water being used in North America, but for certain parts of the water, it's heated in North America, whereas it isn't heated in the rest of the world. We ran an analysis of this to estimate how much the energy impact of these differences was, and it's shown here comparing the Canadian result with that of the UK, as these were the two data sets for which we had the best data in order to run this comparison. What can be seen is the green area is the estimated energy that's going into this additional hot water in Canada, and it has a significant impact on the energy consumption. And if you took it away from the Canadian results, it brings the energy consumption in the Canadian dishwashers down to very close to that of the UK, and it's likely that this is a fundamental cause of the difference in energy consumption. It doesn't, however, get us quite down to where the UK levels are, and there's still quite a big difference. As a consequence, we considered another aspect. We've already discussed in the normalization stage of this webinar the use of powered drying in North America, which isn't used elsewhere. You may recall that we decided to normalize the results in North America by adjusting them so that they were the full cycle results in which the powered drying was switched on. If we reverse that normalization step and look at the results before the powered drying is switched on, you can see that the difference in energy consumption is shown by this purple area on the graph. Taking away that energy consumption from the Canadian result without the hot water included also brings the average energy consumption of Canadian dishwashers down almost entirely in line with that of those in the UK. Whilst this is only a first order analysis, there's enough confidence in the level of magnitude to suggest that not only are the additional energy consumption of dishwashers in North America real, but the cause of that extra energy consumption is very likely to be a combination of these two factors: extra hot water being used and the use of powered drying. Having established that the differences between marketplaces for energy consumption is genuine, let's consider what's happened to energy efficiency. Given that energy consumption has been falling steadily in all markets and capacities have remained relatively stable, it isn't a surprise to see that the basic energy efficiency metric of consumption divided by capacity has been falling steadily in all markets, too. The only real difference of this graph to the previous ones is that given that Australia has larger dishwashers and similar energy consumption to the European and Korean markets, the impact of the larger models shows here, with efficiencies being slightly better than those in other markets. The energy efficiency index is a mechanism to compare products of all sizes together without having any impact from scale effects. What that means in reality is that you look at the annual energy consumption of the dishwasher, a combination of a number of cycles per year plus some assumptions around standby power, and compare it with a standard model of that capacity. The results here for the energy efficiency index are very similar, and in fact the Australian result has moved closer to the rest of the those in the European and Korean markets as a result of the energy efficiency index taking into account scale effects. However, Australia still has a much better performer in terms of EEI, and it's significant enough for us to look into it to see if we can establish what causes Australian dishwashers to be apparently more efficient. The first thing to note when looking at the better performance of Australian dishwashers is a difference between the reporting requirements in Australia and other markets, and we're going to focus on the EU as an example. You can see on the screen an energy label from the EU and Australia. Both of them show the energy values, a rating and the annual energy consumption. But the EU label has a number of other aspects: water consumption, drying index, cleaning index and noise, and it's the cleaning index that we'll focus on here, looking at the numbers in the tables below. In Australia we have a minimum cleansing index. This is a minimum standard, and the performance of cleaning is not reported beyond that. In the EU we have a label classification. Now, given that cleaning is the primary purpose of a dishwasher, manufacturers have been putting dishwashers in the EU test using a cycle that's designed to achieve the main A rating, the top rating of A, and in fact almost all dishwashers do. You'll notice that the minimum requirement in Australia of 0.9 is equivalent to a C label rating in the EU. Now I'll say again, the cleansing indices are not exactly the same, but they are likely to be similar, and if we assume that they are the same, this means that the Australian test allows manufacturers to tune to a equivalent to a C rating in the EU and then optimize the performance of the dishwasher for energy and water consumption after that, whereas in the EU manufacturers are optimizing after tuning the dishwasher to get a cleansing index of A. This is likely to have some energy penalty in the EU test, and as a consequence this might be part of the reason that the Australian dishwashers, many of which are imports from other markets including the EU and Asia, and therefore ought to be very similar in terms of performance, this might be one of the reasons that they are performing better in the energy efficiency comparisons. We don't know to what extent this difference in reporting affects energy efficiency, however, so we should look at what else might be causing the better performance in Australian dishwashers. The next thing to consider is that consumers in Australia may be actively choosing better dishwashers. This graph shows the average product available, the product weighted average, at the top as a solid line, and the average product bought by Australian consumers, the sales weighted average, as the bottom line, the dotted line. This is a fairly significant difference not seen in other markets, and so initially you may draw the conclusion that Australian consumers are indeed actively choosing better performing dishwashers, and this is part of the reason for their relatively better performance compared to other markets. We should have a note of caution again though. Looking at this graph, which shows all the products in Australia sold in 2009 using the Australian Star Rating Index, which is a similar thing to the Energy Efficiency Index in the EU for different label categories in Australia, each dot on this graph is an individual model that was sold, and the circles represent the sales of that model, with the larger the circle, the higher the volume of sales for a given model. What's clear is that whilst the vast majority of sales are for dishwashers of capacity 12 or 14 place settings, there are an awful lot of dishwashers scattered around with very few sales altogether. Now, the Australian system has a very good product registration database, and they're very good at capturing every single sale of a dishwasher. It's mandatory to report them, and therefore it's possible, and in fact likely, that the Australian system is capturing the sales of older machines at very low volumes from around the marketplace that are not being captured elsewhere. Now, if, as is likely given the downward trend in consumption, these small numbers of sales of older machines are influencing the average energy consumption of the products on sale in a negative way, because the older machines have higher energy consumptions and therefore are pushing up the average, it's possible that the difference between the average product bought and the average product sold is more to do with the capturing of the older products that are being sold several years after they were released onto the market than it is to do with consumers actively choosing more efficient models. We don't know again the scale of this though, so it's still possible that the Australian consumers are part of the reason for the better performance in Australia by actively choosing more efficient models. So if we look at that again though, the sales of dishwashers are, as I've already said, very much focused around the 12 and 14 place setting. If you look at the sales for 12 place settings, you can see by the circles that they are relatively evenly distributed amongst the middle range of energy labels. There's no obvious sign there that consumers are buying significantly more of the more efficient models than the less efficient models. Looking at the 14 place setting machines, this is not the case. Australian consumers do appear, for the larger 14 place setting machines, to be buying significantly more of the more efficient models. But also, a key thing to note here is that as a general trend, the larger 14 place setting machines are more efficient. The products are grouped around the 2.5 to 4 label category compared to the 12 place setting machines, which go down to 1 and up to 3.5. Given that we know Australian consumers are buying larger models than elsewhere, it could simply be a fact that the need for larger dishwashers in Australia, or the desire for larger dishwashers in Australia, is inadvertently driving the more efficient average for the Australian market. In summary, we don't know for sure what is causing the more efficient dishwasher purchases in Australia, but it could be one of a number of factors, including different reporting regimes, different registration systems, a desire to buy larger models, and a desire of consumers to buy more efficient models. It's worth considering whether the data tells us anything about the causes of the improvement in efficiency in dishwashers over time, so that we're able to establish whether or not there's significant scope to continue to drive efficiency further. The Australian analysis showed us that even using an energy efficiency index metric, which is supposed to remove capacity effects, the larger 14 and 15 place setting dishwashers are more efficient than their smaller counterparts. The data on this slide shows average energy consumption of dishwashers over time in both Australia and the UK. Somewhat surprisingly, and unlike other domestic appliances where large capacity tends to mean larger energy consumption, for dishwashers the 14 and 15 place setting machines are in fact using less energy than the 12 or 13 place setting machines where the bulk of the market sits. It's not clear why this is, but having taken some advice from experts in dishwasher technology, it appears that in order to deliver the space saving required in order to accommodate the additional place settings within a unit of a fixed footprint, technologies are being introduced that save space but that also reduce the amount of water used and as a consequence reduce the energy use. So that's part of the driver for the fact that these larger machines are using less energy. It's also that these things tend to be introduced into the premium models, and it's the premium models where we also see the other technological improvements introduced that are specifically designed to reduce water consumption and reduce energy, because consumers at the premium end of the market expect to have the best ratings for their energy labels and water consumption and so on. It's not the job of the annex to look specifically at technology itself, but to give an example of the sorts of things that are being implemented. We're talking about improvements to filter design, improved pump motor efficiency, looking at alternating the pumping of water to the upper and lower spray arms separately and therefore reducing the amount of water needed, or for example moving the heater from the tub to the water sump, which again requires less standing water. So these sorts of technologies are being introduced at the premium end of the market to facilitate space and efficiency improvements, and this is an indication that these sorts of technologies can be rolled out to the rest of the market to improve efficiency, although of course all of them come with a cost premium, and so there are cost implications of doing that. The good news is that you can see from the graphs at the top right hand corner, which show the percentage of sales in each of the UK and Australian markets going to each of the capacity settings, you can see that the sales of the larger machines in the most recent years has been increasing, and so this indicates that there's an appetite within the market for these premium, more expensive but more efficient machines. One other aspect of improving efficiency appears to be the increasing program cycle time that's becoming prevalent in many markets. Not many countries had data on cycle time, and the data we did have is a little bit patchy, so these results need to be watched with a little bit of caution. But despite the uncertainties in the coverage of the data sets, what's clear is in the three markets for which we do have data, Denmark, Australia and the Republic of Korea, cycle times have been increasing significantly. It's clear that this trend is driven at least in part by improving energy consumption. You can achieve the same amount of cleaning for less energy if you take longer to do it, and that therefore this trend is a critical part of the improvements in efficiency of dishwashers over time, although to what extent is unknown. The only thing to point out about this is that it's possible that this is just a test phenomenon. If dishwashers are being designed for the test to run these very lengthy programs which are not acceptable to consumers, it's likely that the real use of dishwashers is different and that consumers are switching to faster programs which use more energy. If this is the case, then the test methodology is not reflective of real use, and that of course is not the aim of a test methodology. There's no evidence for this either way. Anecdotally, many Europeans at least will run a dishwasher overnight, and so a long cycle time is not necessarily a problem. But policymakers do need to be aware that this is an aspect of improving efficiency of dishwashers, and if it isn't reflective of real use, then things probably ought to be changed in either the test methodology or that consumers need to be encouraged actively to use these longer, more efficient. Having seen all of the results of the analysis, it's now time to look and see whether we can establish any link between the policies that are in place in the different markets and the energy performance of dishwashers. We're going to use two case studies, the European Union and North America. The first policy intervention in the EU for dishwashers was the introduction of energy labels in '99, which are shown here with the labels A, B, C and D against the Energy Efficiency Index on the left-hand side. Early data is patchy from the European Union, but it's clear that the downward trend around the boundary of the introduction of these labels is fairly strong. This suggests that the labels have had impact. It's unclear exactly how much of an impact they had and to what extent these trends would have happened anyway, but it seems fairly clear that the early European labels were contributing to the improved performance of dishwashers. The next intervention in the EU was the 2011 MEPS. These were set at a level of 70, an EEI of 70, and the evidence is unclear as to what effect these have had. Between 2003 and 2011 there was a fairly steady but incremental downward trend in energy consumption or energy efficiency of dishwashers, and around the boundary of the introduction of these 2011 NEPs, there's no clear indication that they had an impact on that downward trend. This isn't to say that they didn't have an impact, it's just to say that there's no clear evidence of a link between the introduction of the MEPs and a downward trend. However, the next set of measures, which I'll look at together, with the introduction of a revised label in 2011, in December 2011, the introduction of the A plus to A triple plus energy label categories, and then the 2013 introduction of MEPs, which were not in place at the time of the data but were visible to manufacturers at the time of the analysis. You can see from this graph now two things. First of all, we have data for the EU in the EU as a whole, Austria and Denmark. Now in Austria there's a fairly clear downward trend between 2011 and 12, which you can suggest is linked to the introduction of the new label and the impending MEPs. In Denmark it's much less clear, and in the EU it's somewhere in the middle, which would make sense as a hybrid of the different results from the different markets. We don't have UK data as it stops in 2011, but the small scatter plot to the top right of the screen, which shows the models that were sold of 12 place settings in 2011 in the UK, with the sales of those models represented again by the size of the circles on that plot, shows that nearly all of the sales in 2011 were outside, as in would have failed, the minimum standards that are introduced in 2013. They're nearly all above the dotted brown line, and as a consequence all of those models will not be able to be sold in the EU from 2013. So it's very clear that this will have an impact on the market for dishwashers in the UK by 2013 and 14. The other thing to suggest is that early on the labels had appear to have had an influence, and late on the MEPs and labels appear to have had an influence, but in between there was a very long period of just incremental improvement. The bottom right hand graph shows the percentage of dishwashers in the UK that are given the different energy label ratings, and the purple one is the A rating, which until late 2011 was the top rating. As can be seen, the vast majority of the market have the A level rating by as early as 2006 and certainly by 2008. This suggests that it would have been possible to introduce a revision to the energy labels sooner than that if we wanted to continue to improve the efficiency of dishwashers at a greater rate. And so I think the general message overall is that the interventions in the EU appear to be working, but they need to be timely and they need to be appropriately stringent. Looking now at the impact of policy interventions in the USA and Canada, this is a scatter plot of models available in those two markets in 2012. The MEPS lines shown are for both countries. The solid line is the 2010 MEPS, the dotted purple line is the 2013 MEPS, and the green lines are the Energy Star boundaries for that market for high performing products. You should note that there was no data available for Canadian models. They're expected to be very similar to that in the USA, but they're presented off to the right hand side just to give you an indication of where the standard and compact models, the standard in gold and the compact models in blue, sit relative to the performance standards for those sizes. What's clear is that most of the 2012 models comply already with the 2013 MEPs. There aren't many models that are outside those 2013 MEPs, so it's not going to have a massive impact on the market. There appear to be more in the Canadian dataset than there are in the USA dataset. Some of them have significantly less energy consumption. Specifically looking at the US models in the 14 place setting category, but also there are some over in the Canadian, although as we say we don't know what size those are. There are models there that use 50% less energy than the MEPs. We're assuming that these are actually imported European style dishwashers with a cold fill, although we don't actually know. But it does suggest that there is scope. Both of these facts, the fact that nearly all the models meet the 2013 MEPs in 2012, suggests that there is still scope, and the spread of models suggests that there's still scope to tighten the MEPs further. And of course, given the difference between the North American market and the market in Europe, the implication is that there is scope to improve efficiency, but of course it actually might involve some significant market transformation, changing fundamentally the way dishwashers are bought and used in North America. And so the policy options for North America are many, of course, but they are very complicated, and you need to be aware of the products that are actually in use and where they're coming from, and what the consumer impacts are of any new measures that might be introduced in North America. Looking to the future, we do a couple of small things in the analyses to assess what the opportunities are into the future. We don't do a technological evaluation specifically, but we do look at things like the best performing products that are currently available and how they compare to the averages. Now, bearing in mind the uncertainties of relative performance, there's a little bit of uncertainty here. We're using a best performing product from the Australian market. The average for Australia in 2009, the average dishwasher used 37% more energy than the best performing product. That's a fairly sizable difference, and suggests that even in Australia there's opportunity to drive the efficiency improvements that are available in the best products across the market. Of course, all the other data suggests that the values are even more in other markets, specifically of course in North America, where in Canada and the USA the numbers are 116% and 140%. Those are massive, but again these are slightly different marketplaces. But it's clear that with some potential cost implications, there is already technology available in the market that it could improve the efficiency of the average dishwasher. The next thing we do is to run a very simple future saving potentials model. This model looks at two scenarios: a business as usual scenario with some assumptions around GDP growth and so on, and in this case an absolutely best case scenario model, which is a best available technology, best not available technology projection into the future, assuming that the entire market moves to these best available technologies. So this is, in some senses, certainly at the bottom end, a theoretical maximum savings potential for dishwashers into the future. It's really just to give an indication of the sort of scale of impact that could be had by implementing policy to improve the efficiency of dishwashers. And if you look at this analysis, details of which are available in the benchmarking report, it predicts that the total cumulative savings until 2050 would be over 1,000 terawatt hours, which is a significant number. It's a theoretical maximum, as I said, but it gives some indication of the sort of scope for rolling out efficiency improvements in dishwashers into the future. So the main conclusions we can draw from this analysis are as follows. Firstly, energy consumption of dishwashers has been falling steady since the start point of the analysis, which was 1996. It's fallen in all markets consistently over that time. Dishwashers in Canada and the USA, however, whilst their performance is improving steadily like it is in all other markets, their relative performance is significantly worse. They're using much more energy than those in the EU, Australia and Korea. We looked into this specifically, and the first thing we looked at was capacities, but that is not the cause of the additional energy consumption, because capacities are fairly steady in all markets and very similar. Our understanding is that the main causes of the additional energy consumption in dishwashers in the US and Canada is as follows. The first is the use of powered drying at the end of the cycle to dry the load more thoroughly and more quickly. This clearly has an energy penalty, and it's very common in North America, whilst being not very common at all in other markets. The second is water use, with water being a major contribution to the energy use of a dishwasher. In North America, dishwashers use both more water, and all of the water that they use is hot. In other markets, however, the water use is lower, and the water that is used comes into the dishwasher cold and is only heated for certain parts of the cycle. This combination of extra water that's all hot is the other main contributing factor to the additional energy in the North American dishwasher market. The efficiency of dishwashers in all markets has been improving also, and it appears that the Australian models are the best performers according to the analysis. It's unclear whether this is legitimate or not, however. It's possible that differences in the performance reporting for the Australian market allow the dishwashers there to be tuned for energy consumption slightly more than they are in other test methodologies, and as a consequence they benefit with a lower energy consumption. We don't know to what extent this is true, however, and it's also possible that dishwashers in Australia are either slightly better on average, or that consumers are actively choosing better models in that market. It's also true that they might be choosing just larger models, and it seems that larger models are both more efficient but also consume less energy than their mid-size models. So it could be that it's the prevalence to buy larger models in the Australian market that leads them to have a slightly better average efficiency and consumption overall. The reason that larger models use less energy than their medium-sized counterparts is unclear, but it's thought that there are technological reasons that are causing dishwashers of a higher capacity to use less energy. Some of those are to do with creating more space that happen to save water and energy consequently, and some of those are because the larger models are at the premium end of the market where the consumer expects to also have an efficient model. Another reason that dishwashers might be improving in terms of their efficiency is the use of lengthening programs in the test. Longer program cycle times use less energy, which is fine provided they are reflecting of real use in the market. If they're not reflecting real use, then the test methodology needs to change to reflect real use, or consumers need to be encouraged to use the eco cycles. There is evidence in most markets that the policies used to improve efficiencies of dishwashers, normally minimum energy performance standards or energy labels, are working. But there's also a suggestion that these things need to be updated regularly to help maintain the rate of improvement. And the final conclusion is that the best performing products in the data suggest that there is already scope to have further gains of efficiency within the models already available on the market. Although, of course, as has just been described, there may be some cost implications to that to the consumer. And there's also a significant long-term saving potential for dishwashers if policies are put in place to encourage the uptake of the best available technologies. That concludes this webinar on the dishwashers analysis under the Mapping and Benchmarking Annex. You can find more on the Mapping and Benchmarking website, the link for which is shown here. There are a number of other products which you can review the analysis of, or you can look by country and find all the different analyses that are related to a specific country. If you're interested in more information on the dishwashers report itself, please send your follow-up questions to me at the address below. Thank you for listening.